In this video, we'll be looking at a common example of drawing a Lewis structure. This is something you do frequently in chemistry class. It is a two-dimensional representation of a molecule, and it's actually fairly important to be able to do. So we'll begin here. I have a Lewis structure already drawn for NF3, and I want to point out some of the important features of these Lewis structures that we'll be using as we build them. First of all, you can see that we use the chemical symbols of fluorine and nitrogen, and those represent the atoms, and specifically they represent the kernel or the center of the atom, the nucleus and the internal electrons. We also have on the outside pairs of dots, and each dot represents an electron. So this represents a pair of electrons, and they can be around the outside atoms, or here are some electrons around that center nitrogen atom. And then finally, the last symbol that you'll need to be familiar with are these dashes. And those dashes represent pairs of electrons. And so each one represents, if you will, two dots, something like that. Those are our covalent bonds, and they represent two electrons. So you need to be familiar with these. If you need to, just go ahead and hit replay, and you can listen to this explanation again. If you're ready to move on to step 1, just click continue. The first thing that we need to do is to get a count of all of our valence electrons in the molecule NF3. This is going to be an important part because it is through the valence electrons that these atoms will bond together. So I've included a chart of the valence electrons. You should be familiar with the periodic table, and we simply need to be able to locate our elements on that periodic table, and specifically you would have one with symbols, but specifically we have nitrogen, which would be located right here, and fluorine, which would be located right here. And so this table actually just tells us the number of valence electrons. And so as we compile that, we would add them up by essentially saying that nitrogen has 5 valence electrons, and we just use an E with a negative to symbolize electrons. And fluorine, as you can see, has 7 valence electrons. One thing we have to keep in mind is the subscript 3 tells us that there are 3 fluorines, each of which has 7 electrons. So we would multiply those 7 electrons by 3 to get a total of 21 electrons. And now we take our 5 electrons from nitrogen and add it to our 21 electrons from fluorine atoms, and we have 26 electrons total. And this will be our important number that we will use as we go forward. So our first step, count valence electrons. If you're ready to move on, click continue. If you need to review this, just click replay. Now that we have our valence electrons, 26 valence electrons, we need to determine which of these atoms will be central. And a simple way to do this is basically to look at the formula, and if you have one element that there is only one atom of, and a second element that there are multiple atoms of, the element that only has one will go in the center. The chemical explanation of this is that the atom with the least electronegativity, or the lowest electronegativity, is going to be central. But very often it's easy just to look at the one versus many and put the one in the center. So in this particular case, we can see that there is only one nitrogen and that there are 3 fluorines, which would indicate that nitrogen is likely in the center. And in fact it is. So the second part of this is to draw a skeleton, and that simply means arrange our atoms. We put our nitrogen in a central location, and then surround it with our 3 fluorines. And that is simply all you need to do in this particular case. We create the central atom and surround it with our outside atoms. Once again, if you need to review this, just hit replay. If you're ready to go on to step 3, hit continue. So now that we have a central nitrogen surrounded by fluorines, as we saw in step 2, we need to connect these. These are bonded together, and they're going to connect through our covalent bonds. So if you recall from the beginning, we had a specific symbol for the covalent bonds. Think for a second of what that might be. And all we have to do is add those in. Hopefully you remember, they are the dashes. They represent 2 electrons each. And we will just connect our atoms through covalent bonds. Now, one important aspect of this is that we have our total number of electrons, and we're starting to use them to connect our bonds. So we're going to account for that. We just used 2, 4, 6 electrons, and so I'm going to subtract that from our total, leaving us 20 electrons remaining. So all we've really done here, simple step, is connect our atoms through covalent bonds. If you need to review this, hit replay. Otherwise, hit continue. So we have achieved a connected skeleton, everything connected with covalent bonds. Now what we're going to do is we're going to make sure that what is called the octet rule is satisfied for all of our outside atoms. That is that all of the outside atoms need to have 8 electrons around them. One exception to note is hydrogen. Hydrogen is satisfied with only 2. It just gets what's called a duet. But we don't have hydrogen here, so what we're going to do is we're going to use the symbol for electrons and start to fill in by adding pairs to our outside atoms. And so we'll start and just say that this fluorine currently has 2 electrons. Bonds count as possessed electrons for both atoms. So we'll start to add electrons. There's a pair, there's another pair, and there's a third pair, which would now mean that this fluorine on the left has 2, 4, 6, 8 electrons. I would do the same for the rest of the fluorines and make sure they have 8 valence electrons. Those are the outermost. And because the fluorines are the same, it's pretty easy. One thing to keep in mind is now I've used some electrons. I need to subtract that from my total. I've put 6 on each of the fluorines, which means I've used a total of 18, and I'll subtract that. I have 2 electrons remaining to work with. And this is the compound as it is so far. So if you need to review this, remember all we're trying to do is get 8 electrons out on our external or outside atoms. If you need to review, hit replay. Otherwise, hit continue. At this point, we have a nitrogen surrounded by fluorines, and all of the fluorines have that stable octet or 8 electrons in their outermost energy level. And if you recall, we have 2 electrons remaining. Our last point here would be to make sure that the central atom has 8 valence electrons. That's why things bond, is to have a stable configuration, and 8 is that number. So we're going to use any remaining electrons to get 8 around our central atom. And as you see, nitrogen, our N, has 2, 4, 6 in bonds. And thankfully, we have 2 electrons remaining, so we'll just place those, 1, 2, around our central atom. Subtract that from our total. We end up with 0 electrons, which is great. You always want to end up with 0. And we have our symbol overall, which is what we began with. Actually, I showed you this example at the beginning. But in this particular step, all we wanted to do was give nitrogen, the central atom, 8 valence electrons. And that completes our Lewis structure. If you need to review this particular step, just hit replay. Otherwise, continue. So this is a summary of our steps. Step 1 through 5 will get you to a full valence shell. You can review these on your own. If you need to go over these steps, I have replay here. You can always go back. You can click on any of these steps and it will take you back to that step and you'll be able to see that there. If you're ready to try an example on your own, just simply click Try an Example and follow the steps and you should be able to draw a proper Lewis structure. Here's your example. You can read through it. Take your time, go through the steps, and when you're ready, click Check Your Answer to see how you did. Here's the answer to the Lewis structure for water, H2O. You have your total valence electrons at 8. You have oxygen as your central atom. You have your external atoms have a duet. This is an example. Hydrogen only needs 2. And your central atom has 8 valence electrons. If you need to review, you can always go back to the beginning of this video. Otherwise, practice makes perfect with Lewis structures. Thanks for watching.